Okay, so we have learned a lot about financial maths in the past few videos, and now we're actually getting to the really practical stuff. It's stuff that's actually going on in the world, and that's annuities. Okay, annuities. Very few people have actually 120,000 Rand just to invest once off. So what an annuity is rather than a once-off investment, it's a recurring investment. Okay, so instead of maybe saving 120,000 once off, you rather invest like 1,000 Rand every month. Okay, so it's a recurring investment. So you'll often recognize these ones where they say stuff like every whatever. Okay, every month, or every, not month, okay, or every year, or every 3 months. Okay, but this word every is going to indicate for us that this is recurring. It is not just happening once, it's happening on a regular basis. And it's not just earning interest, okay, it's investing the same amount over and over and over on a certain time period. Okay, so here we go. Here's our timeline. We're going to get the formula for the future value. So we want to know how much will a number of investments be worth at the end of a certain time period, okay, in the future. Okay, so let's say that there are n time periods. So if I count them all the way up, okay, and I'm keeping it very theoretical, okay, there's n time periods. This being time 0, time 1 time period, 2 time periods, 3, all the way up to I, and this goes, no, not I is our interest, let's use K, all the way up to time period K, and this goes all the way up to time period N. Okay, and I'm standing here in the beginning of my time period. Okay, there I am, and here I'm thinking by myself, okay, I want to make an investment. Okay, and at the end of this investment, I want to know how much will it be worth. If I start at time 1, so the end of my first month or first year, I'm going to invest a certain amount. Let's call that amount X. Okay, then I'm going to invest another amount X, and another amount, all the time the same amount, and this goes on after whatever K is. Let's say K is 20 months. After 20 months, okay, again, every month or every year or whatever this time period is, I'm going to invest X. Okay, and all the way up to the very last day, I'm going to invest my last X. Okay, so how much will this be worth? Well, isn't it just N times X? Actually, at this point it is. Okay, I've just put X away, but I haven't said anything about interest. Okay, so if it wasn't for the fact that my X's will actually earn interest, all I would have had was a number of investments under my pillow or wherever I'm putting this money, and it would just be N investments, so N times X. Okay, but as it were, I might be earning interest, or I'm hoping to earn interest. And very important here, I need to work out what is going to be the effective interest rate for every investment. Okay, so every investment has an effective interest rate. So if it's monthly investments, I need to use monthly interest. Okay, very important, it must be effective interest rate. Okay, so let's go and see how am I going to work this out. Well, you recall in just the previous video, we considered how when we have an initial investment and we make deposits during the time period, to treat each deposit as a separate investment. Okay, so imagine I'm going to different banks, different investment companies, every X goes to a different bank account. Okay, that means that I've got a whole set of investments, and right at the end I just add up all of my investments. Okay, and how much will these investments be worth? Well, let's start with the last one. The last one didn't earn any interest. So if my future value is the sum of all these investments, then I'll simply calculate the future value of every investment and add it together. Now that sounds like a lot of work, and it is, but that's what we're doing. We're trying to get a formula to make the work easy. So my last investment, that X, is only worth X because it hasn't earned any interest. The one just before that earned one time period interest. Okay, so that one, X, earned one time period of interest. So the interest, the effective interest rate on that time period, to the power of 1. Okay, the second one before that, okay, there was an X there, earned interest for 2 time periods. Okay, so that one earned interest for 2 time periods, so interest was added twice, and I'm sure you can see where this is going. Okay, so if I do this all the way for every single one, all the way to there, okay, let's try this one, that X. So I've done all the ones in between. How about this X? Well, that X earned interest not for 3 time periods. Okay, that's the number of time periods I'm not counting. In total, there are n. So let's imagine n was 20. Then this one would have earned interest for 20 minus 3, because there's a total of 20, but for the first 3 months it wasn't invested, so it's only invested for 17 months. So how many interests am I adding? Well, depending on the number of n, okay, minus its position, it's number 3. Okay, it's the third investment. Plus the one just before him. I think you're probably seeing where this is going, isn't it? Okay, so that one would be n minus 2. And finally, the last one, and I'm running out of space, or not the last one, actually the very first investment, earned interest not during the first month because it wasn't invested yet, but only during all of the rest of the months. So it didn't earn it for n, because it didn't earn it for the first period, it earned it for n minus 1 time periods. So let's get there. Okay, so it earned interest for n minus 1 time periods. Okay, now I wonder if you are recognizing what this is. First of all, we see a bunch of terms that are added together, and that should make you think of series. This is a series. Okay. Is it an arithmetic series or is it a geometric series? That's the question, because if it is, we have, how many terms do we have? Well, we have n terms in total. If we know it's arithmetic, we have a formula for the arithmetic series. If we know it's geometric, we have a formula for the geometric series. So here's my advice. Pause the video for a moment and see if you can figure out, is it arithmetic or geometric? I hope you paused the video and that you could figure out it's a geometric series. Let's see why. Okay, let's take consecutive terms and divide them. Consecutive terms and divide them. Okay, and in both of these cases, x cancels, and one of the 1 plus i's cancel with one of the 1 plus i's, so that I can find that it has a constant ratio. So do you see 1 plus I? My 1 plus my interest is my constant ratio. So this would be my constant ratio, and my first term would just be x. So that's my first term. Do you recall the formula for the sum of the geometric series? Okay, the sum of the geometric series, a finite sum, is my first term, 1 minus Rn over 1 minus R. So let's just go and substitute in there. We saw our first term is indeed x. My constant ratio is 1 plus I, so 1 minus 1 plus I to the power of n and all this is being divided by 1 minus 1 plus I. Now this can simplify just a little bit, and let me show you what the final product looks like. Okay, so we have x 1 minus 1 plus I to the power of n divided by, in the denominator, the negative gets distributed, so we have 1 minus 1, which is 0, and in the denominator, negative I. Now, just so that we can get rid of the negative I in the denominator, let's multiply with a negative 1 numerator and denominator, and that gives me my final. Okay, the future value after n investments, okay, of x is my recurring investment, is, and this, if I multiply it in, okay, distributed, makes that one a positive and this one a negative. So I'm just going to swap their positions. I have 1 plus I to the power of n minus 1 divided by, and this negative becomes a positive. Okay, there we go. This is the future value of a recurring investment. So the future value formula for the annuity, where Fn is the future value of the annuity, and annuity of n investments. Okay, n investments, very important. They are this recurring investments, so it's the same amount. N investments. X is the recurring investment, so the value of the recurring payment or investment.